Have you ever driven across an entire country? Not just a state, but a journey so long that days blur together? Endless highways, repeating sunrises, a distance so vast that miles stop meaning anything and time becomes the only thing you feel. That creeping exhaustion, that deep, instinctive sense of scale, is the absolute limit of human intuition. Our minds were never built for more than this. We understand distance as footsteps, as rooms, as the wait at a red light. We live at the human scale, safe, familiar, manageable. But what if that sense of vastness is an illusion? What if the universe is not merely large, but so unimaginably immense that it destroys every concept of size your brain relies on? The observable universe spans 93 billion light-years, and within that scale, Earth is not small. It is effectively non-existent, smaller than a single atom in a cosmic ocean. Tonight, we are going to push past the limits of intuition itself. We're going to take a journey that makes a cross-continental drive feel like standing still. A journey that reveals why scale, as you understand it, completely collapses when confronted with the cosmos. If you're ready to leave human intuition behind and see the universe as it truly is, join me. Like this video and subscribe to Cosmo Depth, because once you grasp the true scale of reality, there is no going back. We begin, as we must, at home. Look down at your hand. Clench your fist. The planet we call Earth, this swirling marble of blue and white, is the only home we've ever known. It is the foundation of every story, every war, every love, every fear. Its circumference is roughly 25,000 miles. If you could walk non-stop, without rest, it would take you about a year and a half to circle the globe. That is a long time. That is a great distance. That is the human scale. Now, let's hold a small, perfect marble in our hand. This marble, this tiny sphere, is our Earth. We feel its weight, its coolness, its perfect manageable size. It is a thing we can possess, a thing we can understand. This is the scale of our comfort. Now, let's take a step away. We're going to leave the atmosphere, past the satellites, and look back. The Earth shrinks, but it is still recognizable. It is still home. Our first destination is the moon. In our minds, the moon is close. It is our companion, a familiar, friendly face in the night sky. It is a short hop, a quick trip, right? It's only about 238,900 miles away. That number, 238,900, is just a number. It doesn't feel like anything. But here is where the illusion begins to crack. If you were to take every other planet in our solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, and line them up side by side in a perfect row, they would all fit, with room to spare, in the space between the Earth and the Moon. Think about that. The distance to our closest celestial neighbor is so vast that it can swallow 7 entire worlds. The space we perceive as a small gap is already a cosmic chasm. This is the first lesson of the universe. Everything you think is close is not. We have now left the human scale behind. We are entering the realm of the astronomical unit, or AU. 1 AU is the distance from the Earth to the Sun, about 93 million miles. This is the new yardstick of our solar system. The distance to Jupiter is about 5.2 astronomical units. To Saturn, 9.5 astronomical units. To Uranus, 19 astronomical units. To Neptune, 30 astronomical units. These numbers are cleaner, more manageable, but they still hide the true scale. Let's go back to our cross-country drive. If that drive was one astronomical unit, then the distance to Neptune would be a journey that would take you 30 times longer. 30 cross-country drives, back to back, just to reach the edge of the major planets. But the true edge of our solar system is not Neptune. It is not even Pluto, which orbits at an average of 40 astronomical units. The true boundary of our home is a vast spherical shell of icy debris called the Oort cloud. This cloud is the deep freeze reservoir of comets, and it is the final true frontier of the Sun's gravitational influence. To reach the inner edge of the Oort cloud, you would have to travel 2,000 astronomical units. To reach the outer edge, you would have to travel 100,000 astronomical units. Let's translate that back into a unit we can feel: the light year. 1 light year is the distance light travels in 1 year, about 6 trillion miles. The outer edge of the Oort cloud is 1.58 light years away. Our solar system, our home, is a bubble of influence that is already over 3 light years across. We are not just a planet. We are a tiny, isolated island in a sea of darkness. This brings us to the one unbreakable rule of the universe: the speed of light. On Earth, we think we know what fast means. A race car at 200 miles per hour feels like flying. A jet at takeoff screams past 600, and the Parker Solar Probe, humanity's fastest creation, dives toward the Sun at more than 430,000 miles per hour, fast enough to carry you from New York to Los Angeles in 6 seconds. The absolute limit of what our minds and machines can grasp as speed. But now meet the real champion: light, which travels at 186,282 miles every single second. Not per minute, not per hour, per second. In the time it takes you to blink, light could circle the Earth 7.5 times. In 1 heartbeat, it could reach the moon and return. And in the 8 minutes sunlight takes to reach us, it crosses 93 million miles of empty space without slowing, without tiring, without ever stopping. Nothing in the universe, no particle, no signal, no information, can go faster, because this is the cosmic speed limit, written into reality by Einstein's special relativity. And because this speed is finite, the universe we see is not the universe as it is now, but the universe as it was when the light left its source, where distance becomes time and time becomes distance, meaning every step away from home is a step backward through history. And the farther we go, the deeper into the past we fall. The speed of light is not just a number. It is the reason the cosmos feels impossibly large, the reason a cross-country drive or even a trip to the moon is nothing compared to what comes next. So hold on to that number: 186,282 miles per second, because we are about to see what it truly means when you let it run for billions of years. This is the universe's ultimate speed limit, and it is the key to understanding the true scale of time and distance. Think about the sun. When you look at the sun, you are not seeing it as it is right now. You are seeing it as it was 8 minutes and 20 seconds ago, because that is how long it takes for the light to travel 93 million miles to your eye. If the sun were to suddenly vanish, we would not know for over 8 minutes. That means that even in our own solar system, we are constantly looking into the past. When you look at Jupiter, you are seeing it as it was 40 minutes ago. When you look at Pluto, you are seeing it as it was 5.5 hours ago. The farther we look out, the deeper we look back in time. The universe is a vast living museum, and every star is a window into a different moment in history. Now we take the step that truly breaks the human mind, leaving the sun's domain and heading into the dark between stars. Our destination is the nearest star system, Alpha Centauri, a triple sun family just 4.24 light-years away. It sounds close, a next-door neighbor in cosmic terms. But let us feel what that really means by returning to our cross-country drive, the one that exhausted you over several days and thousands of miles, and imagining the entire universe shrunk so that drive represents 1 light second. The distance light travels in a single heartbeat. To cover 1 light year at that same speed, you would have to repeat that drive 31.5 million times, back to back, without rest. And to reach Alpha Centauri, you would need to do it more than 133 million times. That is 133 million multi-day road trips, one after another, for your entire life and the lives of everyone you have ever known. While the sun rises and sets on your windshield millions of times, seasons cycle, years blur, civilizations rise and fall, and you are still driving, lost in an endless highway of vacuum with no exits, no gas stations, no towns. Alpha Centauri is the closest star. Everything else is farther, and the space between stars is not just empty. It is a desert so vast that human intuition gives up, because we've left the solar system behind, and the true loneliness of the cosmos has only just begun. Here is a more visceral analogy. Imagine you are walking. You take 1 step every second. To walk 1 light year, you would have to walk non-stop for 19 million years. To reach Alpha Centauri, you would have to walk for over 80 million years. The light we see from Alpha Centauri tonight left that star system when our ancestors were still walking upright, just beginning to master the use of fire. The light has been traveling for 4.24 years, crossing a void so empty, so vast, that it actively defies our ability to imagine it. Our fastest creation, Voyager 1, is a shining example of human skill and daring. Launched in 1977, it is now the farthest object ever sent into space, slipping quietly beyond the sun's reach into the true dark between stars, and for more than 40 years it has raced outward at about 38,000 miles per hour, fast enough to circle Earth 1.5 times in a single hour. But at that blistering pace, how long would it take Voyager to reach the nearest star system, Alpha Centauri? Over 73,000 years, 73,000 years. Longer than all of recorded human history. Longer than the time since our ancestors painted caves or planted the first crops. Longer than the rise and fall of every empire, every religion, every language we've ever spoken. And by the time Voyager drifts past Alpha Centauri, if it ever does, since its path does not even aim directly there, the probe itself will be a cold, silent relic, its power long gone, its golden record a message no one on Earth will remember sending. This is the crushing reality of interstellar space. It is not a neighborhood. It is not even a desert. It is an ocean of time so deep that our fastest machines are reduced to drift in specks, carried by currents too slow to notice in a single lifetime. Because Alpha Centauri is the closest star, everything else is farther, much, much farther, and we've only just begun to feel how alone we really are. We are now ready to step even farther back and see our true home, the Milky Way galaxy, In photographs, it looks like a glowing, elegant spiral, a pinwheel of light we can hold in a single glance on a screen, but that beauty hides its true size. And to feel it, we need an analogy that brings the numbers down to something we can almost touch. Picture a single grain of sand between your fingers. That tiny grain represents our entire solar system. The Sun, all the planets, the Oort cloud, everything the Sun's gravity controls. Now imagine a vast desert stretching 100 miles in every direction, and that desert, every dune and every grain, is the Milky Way. Our solar system is just one speck, lost in that endless expanse, surrounded by roughly 200 to 400 billion other grains, other stars, most with their own invisible solar systems of planets, comets, and dust, while the bright spiral arms we admire are merely the places where new stars are born, lighting up the dust like street lamps in a foggy city. And most of the desert remains dark, quiet, and empty. Stand in that desert and try to find your single grain, and you would be lost forever. Because the Milky Way is not a picture. It is a continent of stars so vast that light takes 100,000 years to cross from one edge to the other, and we live near the edge in a quiet suburb, far from the crowded, brilliant core, meaning we have left the solar system far behind. The galaxy is our city now, and even this city is only the beginning. The Milky Way is immense. It is 100,000 light-years across. It contains between 100 and 400 billion stars. Let's try to grasp that number of stars. If you were to count one star every second, it would take you over 12,000 years to count all the stars in the Milky Way. Our Sun, the star that gives us life, is a completely average, unremarkable star, located about 27,000 light-years from the galactic center. This distance, 27,000 light-years, is a profound measure of time. The light we see from the center of our own galaxy left its source 27,000 years ago. That light has been traveling through space since before the last ice age, since before humans had developed agriculture, since before the pyramids were built. When we look at the center of our galaxy, we are looking at a time when human civilization was still in its infancy. At the very heart of this galactic city lurks a monster we call Sagittarius, a star, a supermassive black hole with a mass of 4 million suns crushed into a space smaller than our solar system, the unseen ruler and gravitational kingpin that keeps hundreds of billions of stars, and us, locked into their vast sweeping orbits, where nothing escapes its influence, and every motion in the Milky Way galaxy, from the glowing spiral arms to the quiet drift of our own sun, obeys its silent command. Yet even this colossal beast is dwarfed by the galaxy's true scale, because the Milky Way is not a frozen picture, but alive, turning slowly like a cosmic carousel, with our solar system racing around the center at about 140 miles per second, fast enough to cross the United States in 20 seconds, and still requiring roughly 230 million years to complete one full orbit, meaning one galactic year equals 230 million Earth years. So the last time the Sun occupied this exact position, the first dinosaurs were just appearing, their entire rise, dominance, and extinction unfolding in less than a single galactic year, and by the time we returned, they were long gone, buried beneath rock as mammals began to rise, while all of human history, from stone tools to cities, rockets, and smartphones, is less than a blink of an eye on this cosmic clock, not even a tiny fraction of one orbit Because the Milky Way does not hurry, it turns with patient, unstoppable majesty, and we are merely passengers on one quiet ride around a very large wheel. This brings us to the concept of cosmic time. Our human intuition is based on a lifetime of 80 years, a history of a few thousand years. But the universe operates on a clock that makes our history an imperceptible flicker. Let's scale the entire 13.8 billion year history of the universe into a single, manageable year, the cosmic calendar. On this calendar, the Big Bang happens at the first moment of January 1st. For the next 5 months, nothing much happens. The universe is a dark, hot, expanding void. The Milky Way galaxy doesn't even begin to form until May. Our Sun and solar system are latecomers, not forming until September 1st. Life on Earth begins shortly after, in mid-September. The first multicelled organisms appear in November. The dinosaurs don't arrive until December 26th. They are wiped out on December 30th. Now, pay close attention to the final day, December 31st. The first humans, our earliest ancestors, appear around 10:24 p.m. All of recorded human history, the invention of writing, the building of the pyramids, the rise and fall of empires, the birth of science, the Industrial Revolution, the entire span of your life, all of it happens in the last 30 seconds of December 31st. 30 seconds. That is the entire scope of human civilization on the cosmic clock. The smallness of Earth is now compounded by the smallness of our time. We are not just a grain of sand in a vast desert. We are a fleeting spark that lasts for less than a minute in a year-long epic. This is the profound, humbling truth of cosmic time. But the journey is not over. We must now leave our island galaxy and look at the cosmic web. We are not alone. The Milky Way is part of a small cluster of galaxies called the Local Group. This group is dominated by two giants, the Milky Way and the Andromeda Galaxy. Andromeda is our closest major galactic neighbor, about 2.5 million light-years away. Let us try to make these enormous distances feel a little more real with a simple analogy. Imagine stretching your arm out in front of you, where the length from your shoulder to your fingertips is one astronomical unit, AU, the average distance from Earth to the Sun, about 93 million miles, and in this model, the entire solar system out to Neptune would fit comfortably in the palm of your hand. Now keep that single arm's length firmly in mind, because the distance to the Andromeda Galaxy, our nearest big galactic neighbor, at about 2.5 million light-years, would on this same scale be roughly equal to the real distance from Earth to the Moon, about 250,000 miles, meaning one simple arm's length to the Sun suddenly becomes a full lunar journey just to reach Andromeda. A jump so abrupt it almost hurts, as what felt like a manageable reach inside our local neighborhood explodes into a gulf no human has ever crossed. And even that is only the beginning, because Andromeda is not alone, but shares space with us inside the local group, a loose family of more than 50 galaxies, mostly faint dwarfs bound together by gravity, stretching across roughly 10 million light-years, about 4 times farther than Andromeda itself, which in our arm-length model would span a distance equal to the real Earth-Sun distance of 93 million miles. At this point, we are no longer talking about a single galaxy, but a small cosmic village, with the Milky Way galaxy and Andromeda as the two largest homes on opposite sides of the neighborhood. While everything else, the Triangulum Galaxy, the Magellanic Clouds, and dozens of dim dwarfs, floats between them, orbiting a shared center of mass like planets around an invisible sun. And although 10 million light-years sounds unimaginably vast, on the scale of the universe, it is tiny, merely our local street, beyond which lie the cities, countries, and continents of galaxies we have only just begun to glimpse, with the true scale, the one that makes Earth smaller than an atom, still waiting ahead. Even the local group, our cozy gathering of 50-odd galaxies, is nothing more than a quiet suburb in the grand architecture of the universe. Because galaxies do not float alone like random specks of dust, but are bound together in a vast, delicate network. Astronomers call the cosmic web, a structure that can be imagined as a three-dimensional sponge, where bright, glowing filaments of galaxy clusters and superclusters stretch for hundreds of millions of light-years, meeting at massive gravitational knots packed with matter, while between them lie enormous voids, almost empty bubbles, hundreds of millions of light-years across, where hardly any galaxies exist at all. This web is the true skeleton of the cosmos, shaped by gravity pulling matter along the densest paths and leaving the emptier regions hollow, so that up close the universe looks clumpy and chaotic, but from far enough away, a lacy, interconnected foam emerges, filling all of space, with the local group resting on a thin filament that feeds into the Virgo supercluster, itself only a small region within the far larger Laniakea supercluster, a structure spanning more than 500 million light-years. The cosmic web is not static, but still growing and evolving, as gravity slowly draws matter along filaments towards the densest nodes, while voids expand, filaments thicken, and the entire pattern shifts like a slow-motion cosmic tide, meaning we are not just in a galaxy, but on a single thread, in a web that stretches across billions of light-years, so vast that light from one end has not had time to reach the other since the Big Bang, revealing that the universe is not a scattering of islands, but one immense living tapestry. And we are a tiny stitch in one quiet corner. We are part of a supercluster called Laniakea, which means immeasurable heaven in Hawaiian. Laniakea is a colossal structure, 520 million light-years across, containing over 100,000 galaxies. Think of it as a massive, sprawling city, and the Milky Way is just one small neighborhood. This entire supercluster, this immense structure of 100,000 galaxies, is not stationary. It is all moving, flowing, being pulled by an irresistible gravitational force toward a single, mysterious point in space called the Great Attractor. We are not just floating in space. We are surfing a massive cosmic wave of gravity, being drawn toward a colossal, unseen mass. The entire Laniakea supercluster is falling toward this point at a speed of hundreds of kilometers per second. This is the universe's way of reminding us that even at the largest scales, the laws of physics are in charge, and we are merely passengers on a journey we cannot control. The structure of the universe is like a sponge or a honeycomb. The galaxies cluster in long, thin filaments. The walls of the honeycomb, and in the centers of the cells, are the voids, immense, dark, empty regions of space that can be hundreds of millions of light-years across, containing almost no galaxies at all. The universe is not uniformly filled. It is a tapestry of light and shadow, of immense structures and terrifying emptiness. We have traveled from the size of a marble to a structure 520 million light-years across. Now, we must confront the ultimate boundary, the edge of the observable universe. Imagine you are standing on a perfectly flat plain. You can see the horizon. No matter how far you walk, the horizon remains the same distance from you. The horizon is not a physical wall. It is a limit imposed by your own perspective. The observable universe is our cosmic horizon. It is the farthest distance from which light has had time to reach us since the Big Bang. The age of the universe is 13.8 billion years. Therefore, you might assume the edge of the observable universe is 13.8 billion light-years away. But here is the final, mind-bending paradox that shatters all human intuition. The observable universe is actually estimated to be 93 billion light-years in diameter. How can this be? How can the universe be 13.8 billion years old, but 93 billion light-years wide? The answer is the expansion of space itself. Let's use a final, powerful analogy. Imagine you are standing on a massive, stretching rubber sheet. You shine a flashlight. The light travels across the sheet at a constant speed. But while the light is traveling, the sheet itself is stretching. The space between you and the light is constantly being created. By the time the light reaches the edge of the observable universe, the space it has traveled through has expanded, pushing the original source much, much farther away than the distance the light actually covered. The light we see from the farthest galaxies has been on its journey for nearly the entire age of the universe, 13.8 billion years, and in a static cosmos that would place those galaxies just 13.8 billion light-years away. But the universe is not static. It is expanding, with space itself stretching and carrying galaxies along like dots on an inflating balloon, leading to one of the most mind-bending facts in cosmology. Those distant galaxies are now about 46.5 billion light-years from us, meaning the light took 13.8 billion years to arrive, while the space between us grew so dramatically that the source raced ever farther away, and the full diameter of the observable universe, the sphere of everything we can ever hope to see, is roughly 93 billion light-years. This is where human intuition completely breaks. The universe is not just getting bigger, it is creating new distance faster than light itself can travel through it. And beyond that, 46.5 billion light-year horizon lies more universe, perhaps infinitely more, whose light will never reach us because the expansion is too rapid and space is stretching too quickly for those photons to ever catch up, leaving us forever inside our own cosmic bubble. A 93 billion light-year prison whose walls are built from the speed of light and the relentless push of dark energy. This is the edge of everything we can know, the wall at the end of vision, a limit drawn not by technology but by the fundamental rules of reality. We have climbed from a marble in our hand to a sphere so vast that Earth, the Sun, the Milky Way, even the local group are less than a speck, smaller than a single atom compared to the whole. And now, with the largest scale behind us, it is time for the final, most humbling turn. We go the other way, inward, towards the impossibly small. Because the universe is not just bigger than we imagined, it is smaller too, and the journey down will make the journey out feel almost gentle. We started with the Earth as a marble in our hand. Now, let's look at the smallest scale, the building blocks of that marble. We are made of atoms. Atoms are made of protons, neutrons, and electrons. The proton, the heart of the atom, is tiny. Its diameter is about 1.7 femtometers, or 1.7 times 10 to the negative 15th meters. Let's try to ground this smallness. Imagine a single grain of sand. Now, imagine that grain of sand is the size of the entire Earth. On that scale, a single atom would be smaller than a marble. But let's go further. Imagine you are holding a perfect sphere that represents the entire observable universe, 93 billion light-years across. Now, imagine a single atom. The ratio of the size of the observable universe to the size of a single atom is roughly 10 to the 41st power. Here is the final, terrifying paradox of scale. The universe is so vast that the ratio of the size of the smallest thing we can measure, a proton, to the largest thing we can see, the observable universe, is almost the same as the ratio of the size of a human being to the size of a proton. We are suspended almost perfectly in the middle of all things, a tiny, fleeting moment of consciousness between the quantum foam and the cosmic web. The smallness of Earth is not a tragedy, it is a miracle. We are a tiny, wet, blue anomaly in a sea of nothingness. We are a fragile, delicate bubble of life, orbiting an average star in an average galaxy, in a supercluster that is falling toward an unseen mass. But we are also the only place we know where the universe has become aware of itself. We are the consciousness that can measure the 93 billion light-year void and the 10 to the minus 15 meter proton. We are the universe's way of taking its own measure. The journey we have taken from the feeling of a long drive to the edge of forever has been a journey of humility. It has shown us that our human intuition is a beautiful but ultimately limited tool. The universe is not obligated to make sense to us. It is vast, ancient, and indifferent to our existence. But in that indifference lies a profound truth. The fact that we can even ask the question, how small is Earth really, is the greatest triumph of all. We are made of the same stardust that created the galaxies, and we are the only part of that stardust that can look up and marvel at its own origin. The smallness of Earth is not a sign of our insignificance, but a testament to the precious, improbable anomaly of our existence. Hold that marble in your hand and know that it is the most valuable thing in 93 billion light-years. The journey outward from our solar system is not a smooth ride. It is a dive into a darkness so complete that it reshapes what the word empty even means. We have seen that the true boundary of our home, the distant Oort cloud, stretches out to roughly 1.6 light-years, and crossing even that gulf feels impossible once we confront the one rule nothing can break: the speed of light. Our fastest creations, the Voyager probes, are marvels of human ambition, slipping away from the sun at about 38,000 miles per hour. Yet they are also a quiet reminder of our limits, because at that speed, Voyager 1 would need more than 73,000 years to reach Proxima Centauri, the closest star beyond our own. To feel the hopelessness more clearly, imagine the fastest machine we've ever built, the Parker Solar Probe, diving near the Sun at over 430,000 miles per hour, fast enough to cross the United States in seconds. Yet even at that impossible speed, driving day and night without stopping, it would still take nearly 17,000 years to cover a single light year, and over 73,000 years to reach Proxima Centauri at just 4.24 light years away. 73,000 years. longer than all of recorded human history, longer than the time since our ancestors painted caves or built the first cities. The light we see from Proxima tonight left its star when the last ice age still gripped Earth, and our fastest probe, the pinnacle of our technology, would take longer than the entire rise of civilization to get there. Interstellar space is not just far, it is a barrier of time. The universe does not wait for us, it simply keeps expanding while we crawl, and the stars we dream of reaching may have already lived and died by the time we could ever arrive. This is the true meaning of the void. It is not just empty space, it is time made visible. The light from Proxima Centauri, the closest star beyond our Sun, has been traveling for 4.24 years to reach us, which may sound short until you consider what can happen on Earth in 4 years. Empires rise and crumble, technologies reshape daily life, billions of people are born and die, and yet for most of the stars we see at night, the light is far older. When you look at a star 10 light years away, you see it as it was when you were a child. At 100 light years, you look back to the time of your great-grandparents. At 1,000, you peer into the Middle Ages. At 10,000, you watch the dawn of agriculture. The void is a graveyard of moments. Every photon striking your eye tonight is a messenger from a past that no longer exists anywhere else. And the star you admire may have exploded yesterday, flared into a nova, or cooled into a dark cinder, with the truth hidden from us for centuries or millennia. We live surrounded by ghosts, bathed in light that remembers a universe we can never touch. The interstellar dark is not just far, it is ancient, and in that darkness, the true scale of the cosmos finally sinks in. We are not just small in space, we are fleeting in time. The stars are not our contemporaries, they are echoes, and the silence between them is the sound of deep time passing us by. To truly grasp the light year, let's try to ground it in a more physical, human effort. Imagine you are climbing a mountain, a very, very tall mountain. The distance from the Earth to the Sun, 1 astronomical unit, is the equivalent of climbing Mount Everest 1,600 times. Now 1 light year is 63,241 astronomical units. To climb the distance of 1 light year, you would have to climb Mount Everest over 100 million times. It is an effort so colossal, so beyond the capacity of a single human life, that it becomes a philosophical concept, not a physical one. The void is not just empty, it is a profound silence. The only thing that travels at the speed of light is light itself. Everything else, every ship, every probe, every thought is condemned to the slow, grinding pace of matter. The loneliness of interstellar travel is not just the lack of company. It is the realization that you are moving through a space so vast that your journey will outlive your species. The Voyager probes, carrying the golden record, a message in a bottle from humanity, are now in the interstellar medium, the space between the stars. They are traveling at a speed that is utterly insignificant on the cosmic scale. In 40,000 years, Voyager 1 will pass within 1.6 light years of the star Gliese. 40,000 years. The human mind struggled to process this. 40,000 years ago, Neanderthals were still walking the earth. The world we know today would be unrecognizable. And yet, that is the blink of an eye in the life of the cosmos. We are now leaving the sun's gentle pull behind and stepping into the true heart of our cosmic home, the Milky Way galaxy. Picture yourself standing in the middle of a huge, ancient city at night, where lights stretch in every direction like a glowing river of streets and buildings that never seems to end. That city is the Milky Way, our sun, just one of those countless lights, and our solar system a single, quiet apartment on a side street. To feel the real size, return to the dinner plate analogy. If we shrink the entire solar system, the sun, all the planets, even the distant Oort cloud, down to the size of an ordinary dinner plate, then the nearest star system, Proxima Centauri, would be another dinner plate sitting about 10 miles away, with nothing but empty darkness in between. Now, zoom out further, because on this same scale, the full Milky Way would cover the entire continental United States, a sprawling web of dinner plates linked by faint threads of light from coast to coast, while our own plate, our solar system, would not even register as a visible speck, smaller than a single atom in that continent-sized structure. The Milky Way is not a cozy disk we could cross in a lifetime, but a vast living city of 200 to 400 billion stars. About 100,000 light-years wide, slowly turning like a pinwheel in the dark, where light itself needs 100,000 years to cross from one edge to the other. We live roughly halfway out from the center, in a quiet spiral arm, far from the bright, crowded downtown where stars pack together by the millions. We are not at the heart of the galaxy, not even close to the main road, but tucked away in the suburbs of a city so immense that no one has ever seen it all at once. And while the Milky Way is our home, in its true scale, that home is larger than any map we can draw, and we are smaller than we ever imagined. The Milky Way is a spiral of light, 100,000 light-years across. To cross it, light must travel for 100,000 years. Think about the history of human consciousness. The first cave paintings were made about 40,000 years ago. The light from the far side of our galaxy has been traveling for more than twice that time. It has been traveling since before the dawn of human art, before the invention of the wheel, before the first written word. Our sun is not at the center of this city. It is a quiet suburban star, located about 27,000 light-years from the galactic core. The light we see from the core, a brilliant, blinding concentration of stars, is 27,000 years old. When that light began its journey, the Earth was still in the grip of the last ice age. The light has traveled through the spiral arms, past countless stars, through vast clouds of gas and dust, just to reach our eyes tonight. At the heart of this galactic city is the supermassive black hole, Sagittarius A star. It is a gravitational behemoth, 4 million times the mass of our sun. It is the anchor, the silent, invisible engine that keeps the entire 100,000 light-year structure from flying apart. And yet, even this colossal black hole is a tiny pinprick in the vastness of the galaxy. The galaxy is not a static picture. It is a colossal, rotating carousel. Our solar system is orbiting the galactic center at a speed of about 140 miles per second. That is fast enough to circle the Earth in less than 3 minutes. Yet, because the galaxy is so vast, it takes our solar system 230 million years to complete one full orbit. This is the concept of the galactic year. The last time our solar system was in this exact position in the galaxy, the Earth was a completely different world. The supercontinent Pangaea was just beginning to break apart. The first dinosaurs were just emerging. the entire history of the dinosaurs, their 165 million year reign, their extinction, the rise of mammals, the evolution of primates, the entire history of humanity, all of it has occurred in less than one single rotation of our galaxy. The smallness of Earth is now compounded by the smallness of our time. We are not just a grain of sand. We are a fleeting moment in a 230 million year dance. The universe is not just big. It is ancient, and our existence is a mere whisper in its colossal, echoing history. To truly internalize this, we must return to the cosmic calendar. We have already established that the Big Bang is January 1st, and all of recorded human history is the last 30 seconds of December 31st. Let's expand on the profound implications of this timeline. The first stars and galaxies form in the early months of the year. The elements that make up your body, the carbon, the oxygen, the iron, are forged in the hearts of these first massive stars, which live fast and die young, exploding in supernovae. This process, the creation of the building blocks of life, takes until May. Our Sun, a second-generation star, forms in September. Life on Earth begins almost immediately, a single-celled organism in the primordial oceans. For the next 3 months, from September to December, the Earth is dominated by single-celled life. The entire history of the Earth is a long, slow, grinding process of biological evolution. The first complex multi-celled organisms, the ancestors of all animals, don't appear until late November. The Cambrian explosion, the sudden burst of life that fills the oceans with diverse creatures, happens on December 13th. The first land plants appear on December 20th. The first reptiles appear on December 22nd. The dinosaurs, the great rulers of the Mesozoic era, arrive on December 26th. They dominate the planet for 4 days, a colossal reign that feels like an eternity to us. But on the cosmic calendar, their entire history is less than a week. On December 30th, at 6:24 a.m., a massive asteroid strikes the Earth, and the dinosaurs vanish. The rise of mammals, our ancestors, begins on December 30th. The first primates appear on December 31st, around 1 p.m. The first human-like creatures, the hominids, appear at 10:24 p.m. The invention of agriculture, the foundation of all civilization, happens at 11:59:30 p.m. The pyramids are built at 11:59:49 p.m. The birth of Christ is at 11:59:55 p.m. The Industrial Revolution begins at 11:59:59 p.m. The smallness of our time is a profound realization. Every single event that defines us, every empire, every war, every technological leap, is compressed into the final, frantic seconds of a single cosmic year. The universe has existed for 13.8 billion years, and we have been conscious observers for a fraction of a second. This is the ultimate contrast, the immense, crushing scale of cosmic time versus the fleeting, precious moment of human awareness. But the journey continues. We must now look beyond our galaxy, beyond our local group, and confront the structure of the universe itself. We are leaving the city and looking at the entire country. Galaxies, as we have seen, are not isolated. They are threads in a vast, interconnected tapestry. Imagine a colossal, three-dimensional fishing net. The knots in the net are the clusters of galaxies, and the threads are the filaments that connect them. The empty spaces between the threads are the voids. We are part of the Laniakea supercluster, a structure so immense that it contains over 100,000 galaxies. To ground this scale, imagine a single drop of water. That drop of water contains more molecules than there are stars in the Milky Way. Now, imagine a vast ocean. That ocean is the Laniakea supercluster. The Laniakea supercluster is 520 million light-years across. To cross it, light must travel for over 500 million years. The light from the far side of Laniakea began its journey when the first complex life was just beginning to emerge on Earth. It has been traveling through space while the Earth has gone through countless geological and biological changes. This entire supercluster is being pulled toward a single, mysterious point in space called the Great Attractor. This is not a star or a galaxy. It is a massive, unseen concentration of mass, a gravitational anomaly that is pulling everything toward it. We are not stationary. We are surfing a massive cosmic wave of gravity being drawn toward a colossal, unseen mass. The entire Laniakea supercluster is falling towards this point at a speed of hundreds of kilometers per second. This is the universe's way of reminding us that even at the largest scales, the laws of physics are in charge, and we are merely passengers on a journey we cannot control. The structure of the universe is like a sponge or a honeycomb. The galaxies cluster in filaments, separated by vast, empty voids. These voids are immense, dark, empty regions of space that can be hundreds of millions of light-years across, containing almost no galaxies at all. The universe is not uniformly filled. It is a tapestry of light and shadow, of immense structures and terrifying emptiness. The existence of these structures, the filaments and the voids, is a direct result of the Big Bang. The tiny quantum fluctuations in the early universe were amplified by gravity over billions of years, creating the colossal structures we see today. The universe is a vast, self-organizing machine, and we are a tiny, fleeting part of its grand design. We have now reached the largest scale, the incomprehensible vastness of 93 billion light-years. Now, we must confront the ultimate boundary, the edge of the observable universe. The light we see from the farthest galaxies has been on its way for almost the entire age of the universe, 13.8 billion years. Yet because space itself has been stretching the whole time, those galaxies are now about 46.5 billion light-years away. And when we double that to include both directions, the observable universe spans an astonishing 93 billion light-years, a scale at which everyday thinking completely fails. Because light, the fastest thing in existence, has not been able to keep up with the expansion of space itself, with new distance being created faster than photons can cross the old, causing the edge of what we can ever see to race away from us forever. That edge is marked by the oldest light of all, the cosmic microwave background, the faint afterglow of the Big Bang, released when the universe was only 380,000 years old, when hot plasma finally cooled enough for atoms to form and light to travel freely. And it represents the true wall of our observable universe, beyond which everything is hidden not just by distance, but by the relentless stretching of space. Because light from farther regions will never arrive here, no matter how long we wait. We are therefore forever locked inside our own cosmic horizon, a bubble 93 billion light-years wide, bounded by the speed of light and the finite age of everything, having climbed to the absolute limit of the visible, a sphere so vast that Earth, the Sun, the Milky Way, and billions of other galaxies are less than a speck within it. And now, to complete the picture, we turn around. Because the most profound shift is not outward, but inward. For the universe is not just bigger than we imagined, it is smaller too. And the journey down will make the journey up feel almost gentle by comparison. Let's try to ground this smallness. Imagine a single grain of sand. That grain of sand is the size of the entire Earth. On that scale, a single atom would be smaller than a marble. But let's go further. We've journeyed to the edge of the observable universe, a 93 billion light-year expanse that defies our every attempt at comprehension. We have seen that the universe is not just vast, but that the very fabric of space is expanding, pushing the most distant light sources away from us, faster than light itself can travel. We are trapped within our own cosmic horizon, forever limited by the speed of light and the age of the universe. This is the ultimate humbling realization of our cosmic perspective. But the journey is not complete. To truly understand the scale of our existence, we must now make the most profound shift of all: the journey inward. We must leave the macrocosm of galaxies and superclusters and plunge into the microcosm of the atom, the building block of everything we know. Imagine, for a moment, that you are holding a single grain of sand. This grain of sand is the Earth. Now imagine that grain of sand is the size of a football stadium. On that scale, a single atom would be too small to see with the naked eye. But let's go deeper. The atom itself is mostly empty space. If the nucleus of an atom were the size of a marble placed at the center of a football stadium, the nearest electron would be a speck of dust orbiting in the nosebleed seats. The rest is the void, the same terrifying, crushing emptiness that separates the stars also exists within the matter that makes up your hand. The universe is not just vast on the outside, it is vast on the inside. We are made of atoms, and those atoms are made of subatomic particles: protons, neutrons, and electrons. The proton, the heart of the atom, is tiny. Its diameter is about 1.7 femtometers, or 1.7 times 10 to the negative 15th meters. This is a number so small that it is meaningless to our human intuition. Let's try to ground it. Imagine you are holding a perfect sphere that represents the entire observable universe, 93 billion light-years across. Now, imagine a single proton. The ratio of the size of the observable universe to the size of a single proton is roughly 10 to the 41st power. Here is the final, mind-bending paradox of scale. The universe is so vast that the ratio of the size of the smallest thing we can measure, a proton, to the largest thing we can see, the observable universe, is almost the same as the ratio of the size of a human being to the size of a proton. We are suspended almost perfectly in the middle of all things, a tiny, fleeting moment of consciousness between the quantum foam and the cosmic web. We are the midpoint of the universe. We are the scale at which the immense emptiness of the cosmos meets the immense emptiness of the atom. We are the bridge between the macrocosm and the microcosm. This is the true scale of our existence. We are not insignificant. We are the universe's way of taking its own measure. The journey inward into the quantum realm reveals a world as bizarre and counterintuitive as the cosmic web. We leave the comforting certainty of classical physics and enter a domain where particles can exist in multiple places at once, where observation changes reality, and where the very concept of location becomes fuzzy. Imagine the feeling of certainty you have when you know exactly where your car keys are. That certainty is the foundation of your daily life. Now, imagine that the keys are simultaneously in your pocket, on the table, and under the couch, and only by looking at them do they decide where they truly are. This is the quantum world. The electron, that tiny speck of dust orbiting the marble-sized nucleus in our stadium-sized atom, is not a planet in a miniature solar system. It is a cloud of probability. It is a wave of potential that only collapses into a particle when we try to measure it. The universe, at its most fundamental level, is not a machine. It is a thought. This quantum uncertainty, this fundamental fuzziness at the heart of matter, is the engine of the universe. It is the tiny random fluctuations in the early universe that were amplified by inflation and gravity to create the galaxies and superclusters we see today. The vast structured cosmos is built on a foundation of fundamental randomness. The paradox deepens. The immense structured order of the 93 billion light-year universe is a direct consequence of the ultimate fundamental disorder of the quantum world. The universe is a colossal, self-organizing system that emerges from chaos. We are, therefore, a product of both the largest and the smallest scales. Our consciousness, our ability to think and reason, is a product of the chemical interactions of billions of atoms, each governed by the bizarre rules of quantum mechanics. Our bodies are made of stardust, forged in the hearts of long-dead stars, and those stars are organized into galaxies that are themselves mere threads in the cosmic web. The smallness of Earth is a constant, haunting theme, but it is a smallness that is defined by its uniqueness. In the entire 93 billion light-year expanse, we have yet to find another place where the conditions for life are so perfectly met. Imagine the sheer, improbable luck of our planet. We are orbiting a star that is stable, long-lived, and just the right size. We are in the Goldilocks zone, a narrow band of space where water can exist as a liquid. Our planet has a massive moon that stabilizes our axial tilt, preventing wild, catastrophic climate swings. We have a massive neighbor, Jupiter, that acts as a cosmic vacuum cleaner, deflecting comets and asteroids that would otherwise sterilize our world. The Earth is not just a planet, it is a cosmic anomaly. It is a fragile, delicate bubble of life in a sea of nothingness. The smallness of Earth is not a sign of our insignificance, but a testament to the precious, improbable anomaly of our existence. The journey we have taken is a journey of perspective. We have seen that the universe is not just big, it is a constant, terrifying, and beautiful reminder of our own limitations. We've seen that the very concept of distance is a human construct that breaks down at the cosmic scale. We've seen that the concept of time is a human experience that is dwarfed by the immense, echoing history of the cosmos. But in this realization of our smallness, there is a profound liberation. We are not the center of the universe, but we are the consciousness that can measure the universe. We are the universe's way of taking its own measure. We are the only part of the stardust that can look up and marvel at its own origin. The smallness of Earth is not a sign of our insignificance, but a testament to the precious, improbable anomaly of our existence. Hold that marble in your hand and know that it is the most valuable thing in 93 billion light years. The true scale of the universe is not a measure of distance, but a measure of wonder. And the true answer to the question, how small is Earth really, is this: It is small enough to be precious and large enough to contain everything that matters. Thank you for taking this journey with me. This is Cosmo Depth, and the cosmos is waiting. The journey we have taken from the familiar comfort of a cross-country drive to the terrifying expanse of the 93 billion light-year observable universe has been a systematic dismantling of our human intuition. We've seen that distance is a measure of time, and time is a measure of cosmic indifference. But to truly appreciate the scale of our existence, we must now linger on the concept of cosmic time and the profound, slow-motion violence that forged the very atoms in our bodies. We established that the entire 13.8 billion year history of the universe can be compressed into a single cosmic year, with all of human history occupying the last 30 seconds of December 31st. This is a powerful analogy, but it hides the true, grinding, geological pace of cosmic evolution. Let's rewind the clock to the first few moments of January 1st, the Big Bang. In the first fraction of a second, the universe expanded faster than light in a process called inflation. This is the engine that created the 93 billion light-year expanse we see today. The universe was a hot, dense soup of energy, a place where the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces were unified. As the universe cooled, these forces separated, and the first subatomic particles, quarks and leptons, began to form. This is the ultimate contrast to our human experience of time. A single second on the cosmic clock contained more dramatic, fundamental change than all of recorded human history. After about 3 minutes, the universe was cool enough for the first atomic nuclei to form, hydrogen and helium. This is the primordial gas, the raw material of the cosmos. For the next 380,000 years, the universe remained a dark, opaque fog, a plasma of charged particles where light could not travel freely. This is the cosmic dark age, a period of profound, silent waiting. Then, on the cosmic calendar, around January 20th, the universe cooled enough for electrons to combine with the nuclei, forming the first neutral atoms. This event, called recombination, allowed light to travel freely for the first time. This is the light we see today as the cosmic microwave background, the oldest light in the universe, the wall of our cosmic horizon. But the universe was still dark. There were no stars, no galaxies, just vast clouds of hydrogen and helium gas. This is the true, profound emptiness of the early cosmos. It took hundreds of millions of years, until around May, on the cosmic calendar, for gravity to slowly, inexorably pull the densest pockets of gas together. These first stars, the population 3 stars, were colossal. They were hundreds of times the mass of our Sun, and they burned with a ferocity that is unimaginable. They were the universe's first factories, the alchemists that took the primordial hydrogen and helium and forged the first heavy elements: carbon, oxygen, nitrogen, and iron. These stars lived fast and died young, exploding in cataclysmic supernovae that scattered their newly forged elements across the cosmos. This is the ultimate contrast to the human experience of life and death. The death of these first stars was not an ending. It was the beginning of everything. Every atom of carbon in your body, every atom of oxygen you breathe, every atom of iron in your blood was forged in the heart of a star that died billions of years ago. The universe is not just a place, it is a process. It is a vast, slow-motion, self-organizing machine that took billions of years to create the conditions for life. The smallness of our time is a constant, haunting theme, but it is a smallness that is defined by its uniqueness. We are the fleeting moment of consciousness that can look back at this colossal, echoing history and understand the process that created us. The formation of the Milky Way, our galactic city, around May on the cosmic calendar, was a violent, chaotic process of mergers and collisions. Our Sun, a second-generation star, formed around September 1st, a star enriched with the heavy elements scattered by the death of the population 3 stars. The Earth, our marble, formed shortly after, a tiny speck of rock and metal orbiting a star that is itself a speck in a galaxy of hundreds of billions. The smallness of Earth, set against a 93 billion light-year cosmos, is a haunting truth. But it is a smallness made precious by its rarity. Across everything we can see, we have found no other world where the conditions for life line up so perfectly. This idea sits at the heart of the rare Earth hypothesis. Our planet is not merely one of many, but a cosmic outlier, the product of an almost impossibly fortunate chain of events that allowed complex life to emerge and endure. It is like winning the biggest lottery imaginable, except the odds are trillions of times worse. So small that Earth feels like the only ticket that ever hit the jackpot. First came the right star, our Sun, a calm, middle-aged G-type main sequence star, stable for billions of years, unlike the flaring red dwarfs that dominate the Milky Way galaxy, or the massive stars that burn out too quickly for life to gain a foothold. Then, the right orbit. Earth sits in the habitable zone, where water can remain liquid and follows an almost perfectly circular path, avoiding lethal swings between deep freeze and runaway heat. Next, the right planet, rocky, just massive enough to hold a thick atmosphere and maintain a molten iron core, whose motion generates a powerful magnetic field, an invisible shield that deflects the sun's solar wind and cosmic radiation, without which our atmosphere would erode and our oceans would be stripped away. The right moon is another stroke of luck, unusually large for its planet. Born from an ancient collision, it stabilizes Earth's axial tilt and prevents wild climatic chaos that would have erased complex life before it could evolve. And finally, the right neighbors. Jupiter, the gentle giant whose immense gravity acts as a cosmic bodyguard, sweeping up or redirecting many comets and asteroids that might otherwise devastate the inner planets and repeatedly reset the clock on life. All these elements, stable star, precise orbit, protective magnetic field, stabilizing moon, and planetary shield, had to align. Miss just one, and complex life likely never gets a chance. In the immensity of 93 billion light-years, Earth stands out not because it is ordinary, but because it is extraordinarily lucky. Our smallness is not a curse, it is the signature of something rare and irreplaceable, a single blue marble where the universe, against all odds, learned to look back at itself. The smallness of Earth is a constant, haunting theme, but it is a smallness that is defined by its uniqueness. It is a fragile, delicate bubble of life in a sea of nothingness. The smallness of Earth is not a sign of our insignificance, but a testament to the precious, improbable anomaly of our existence. Now, let us return to the grandest scale of all, the cosmic web, and face the invisible forces that truly rule it, dark matter and dark energy. Picture walking through a vast ancient cathedral at night. You can see the glowing stained glass windows and the towering stone pillars catching faint moonlight, but not the air that carries every whisper or the hidden strength in the arches that keeps the roof from collapsing. That is our universe, where the shining parts, stars, galaxies, and glowing gas, make up only about 5% of everything that exists, while the rest is hidden, mysterious, and completely in charge. Dark matter, about 27%, is the unseen scaffolding holding the cosmic web together. We cannot see or touch it, detecting it only through its gravity. Yet galaxies spin far too fast to remain intact with visible matter alone, and galaxy clusters would fly apart without an invisible glue. Dark matter is that glue, the quiet hand that pulled ordinary matter into long filaments and dense knots, without which the cosmic web would never have formed, and there would be no galaxies, no stars, no us. Dark energy, the strangest component at 68%, is like an invisible engine pushing the accelerator of the universe, a repulsive property of space itself that speeds up cosmic expansion, sending distant galaxies racing away faster than light could cross the growing gap and inflating the observable universe to 93 billion light-years despite a 13.8 billion year age. Without it, gravity would slow everything down, but instead, the cosmos accelerates, voids widen, and the horizon retreats forever. Visible matter is the decoration. Dark matter is the hidden architecture. Dark energy is the wind pulling the cathedral apart. Together, they remind us that what we see, the glowing threads of the web, the countless suns in distant galaxies, the ancient light arriving after billions of years, is only a tiny fraction of what is really there. And yet, from a small world in a quiet corner of that web, we have learned to measure it all. That is the real wonder. Not just how vast the darkness is, but that we, brief sparks in the dark, have found a way to see it anyway. The universe is a place where the visible is a tiny, fleeting exception, and the invisible is the rule. We are made of the 5% of matter that is visible, but we are living in a universe that is 95% mystery. The smallness of Earth is a constant, haunting theme, but it is a smallness that is defined by its uniqueness. We are the consciousness that can measure the 93 billion light-year void and the 10 to the minus 15th meter proton. And we are the consciousness that can deduce the existence of the 95% of the universe that is invisible. We have traveled from the familiar, tangible world of the human hand to the incomprehensible scale of the 93 billion light-year observable universe. We have confronted the crushing emptiness of the void, the immense indifference of cosmic time, and the fundamental mystery of the dark forces that govern 95% of reality. But the journey is not merely about size, it is about destiny. The ultimate scale of the universe is not its current size, but its ultimate fate. A fate that is being written right now by the most mysterious force of all, dark energy. Imagine for a moment that you are watching a massive, ancient clock. For billions of years, the hands of this clock have been moving at a steady, predictable pace, governed by the pull of gravity. The galaxies, the clusters, the superclusters, all of it was slowing down, a natural consequence of the Big Bang's initial explosion. This was the universe we thought we knew. Then, around 5 billion years ago, something changed. The clock began to speed up. the expansion of the universe, which should have been slowing down due to the mutual gravitational attraction of all matter, began to accelerate. This is the effect of dark energy, the 68% of the universe that is pushing everything apart. Imagine throwing a ball straight up into the air. You watch it rise, slowing under gravity exactly as expected, reaching the top of its arc before falling back towards your waiting hand. That was once our picture of the universe, expanding after the Big Bang and then gradually slowing under its own gravity, perhaps even reversing and collapsing someday. Now imagine that halfway up, an invisible force suddenly grabs the ball and hurls it away, faster and faster, until it vanishes forever. That force is dark energy, not content to let the universe merely coast outward, but actively pushing, accelerating expansion with a strength we can measure but cannot explain. So galaxies already receding now race away even faster, and the space between clusters isn't just growing. It's being driven apart by something woven into reality itself. The consequences are chilling. In the distant future, this acceleration will empty our sky, as galaxies beyond our local group slip over the cosmic horizon one by one, their light stretched into invisibility, until the Milky Way galaxy, and later its merged descendant, Milkomeda, stands alone in an endless, freezing dark. The observable universe will seem to shrink around us, not because it is smaller, but because dark energy has pushed everything else beyond reach. We are living in a brief golden era, when the cosmos is still visible in its full glory. Billions of years from now, future astronomers may look up and see only their own galaxy, with no trace of the billions beyond, and conclude the universe is small, static, and centered on them. Dark energy is not just making the universe bigger, it is erasing its history from view. And in the deepest future, when acceleration has torn apart even the largest structures, the cosmos may end not in fire or ice, but in a cold, lonely whisper. Everything isolated, everything forgotten, an invisible push that is already shaping the universe's final scale. Right now, while we still have time to look up and witness the whole magnificent, terrifying show. The smallness of Earth is now compounded by the smallness of our future. The accelerating expansion means that, in the distant future, the light from all but the closest galaxies will be stretched so much by the expanding space that it will never reach us. The universe will become a vast, cold, empty void, where the Milky Way is an isolated island, surrounded by an eternal, impenetrable darkness. This is the Big Freeze, the most likely fate of the cosmos. In 1 trillion years, the stars will have burned out. The last red dwarfs will have faded, and the universe will be a sea of black holes, neutron stars, and cold, dark matter. The smallness of Earth is not just a measure of its size, it is a measure of its fleeting moment in the sun. We are living in the golden age of the universe, a brief, luminous moment when the stars are shining and the galaxies are visible. But the philosophical implications of dark energy go even deeper. If the universe is accelerating, it means that the space between us and the most distant galaxies is growing so fast that they are already receding from us at speeds greater than the speed of light. This is not a violation of Einstein's theory of relativity, because it is the space itself that is expanding, not the objects moving through the space. The smallness of Earth is a constant, haunting theme, but it is a smallness that is defined by its uniqueness. We are the consciousness that can measure the 93 billion light-year void and the 10 to the minus 15th meter proton. And we are the consciousness that can deduce the existence of the 95% of the universe that is invisible, and the ultimate fate of the cosmos. The journey we have taken from the familiar, tangible world of the human hand to the incomprehensible scale of the 93 billion light-year observable universe has been a systematic dismantling of our human intuition. We have seen that distance is a measure of time, and time is a measure of cosmic indifference. But to truly appreciate the scale of our existence, we must now linger on the concept of cosmic time and the profound slow-motion violence that forged the very atoms in our bodies. In the end, the 93 billion light-year secret is not that Earth is small, but that something so small can hold the universe in its mind. We are a fleeting whisper in an eternal storm, yet the only whisper capable of hearing the storm and calling it beautiful. Hold the marble close, look up one more time, and remember, in all that vastness, the greatest wonder is you.